Hello, this is Arun Pasuparthi, and I welcome you back to the video series of how to crack the OCMJEA exam. I'm going to walk you through an important OCMJEA exam topic today. Now, this belongs to a category called Application Design Concepts and Principles. Today, we are going to see a little more about identifying non functional and quality of service requirements. Now, as I mentioned earlier, all the OCMJEA topics are very, very relevant in your day to day professional life as an architect. Unlike other certification exams where some of the certification concepts are not used in real world, OCMGA exam is entirely different, right? Like the exam topics and scope is filled with content that is very, very relevant in order to make you successful as an architect, especially as a Java solution architect. Today's video, we're going to focus about non-functional requirements or quality of service requirements. Now, one of the very most important jobs of an architect is to define quality of service measurements. Then the architect has to design and architect the system to meet those service level agreements. Now, the agreement to meet this quality of service measurement is called a service level agreement, which is often called SLA. The created architecture must address those non functional requirements in such a way that they complement the functional requirements. At the same time, they satisfy the service level agreements, right? It's very simple. However, a lot of architects struggle in this area because of lack of understanding of each of these service level agreements. This is um, this is this takes you one step closer towards being a good architect. The basic difference between a good and a bad architect is addressing of non-functional requirements along with functional requirements. So if you go to Wikipedia and search for non-functional requirements, you can probably find a huge list of them. While all of them are valid, there are top 8 non-functional requirements that every architect should be gaining mastery in, and those are very important for the exam too. So I've made it easy for you to remember them. uh, all you need to do is to remember the word spammers. Okay, so it is 1 2 3 4 5 6 7 8 letter word, and this word will help you remember all the important non-functional requirements at any point of time, whether it is an interview, whether it is you're trying to answer a question when somebody is asking you about what kind of non-functional requirements you are addressing, or whether it is for the exam. Okay, each letter in the word spammers stands for one aspect of a non-functional requirement, and each letter here is very important to remember. The first one is scalability, performance, availability, maintainability, manageability, extensibility, reliability, and security. I recommend that you take a screenshot of this particular slide or this particular point in the video, and take a print of it and put it somewhere where you can see every day, so that until you kind of remember this by heart. Okay, because these are very important aspects, and I'm going to walk you through each of them, starting from scalability now. Scalability is the capability of a system, network, or a process to handle a growing amount of work, or its potential to be enlarged to accommodate that growth. Now, this might sound a little complicated for some of you. For some of you, it might sound very simple, but let me simplify it anyway. Okay, now scalability is nothing but a degree to which a system allows expanding its own capacity so that the system can serve more requests or do more processing or take up greater workload. Now, system needs to be scalable. If an architect or a designer is designing a system in which it is not scalable in nature, then it's a bad architecture in the first place. System needs to be scalable, whether it is a single tier or two tier or three tier or n tier, irrespective of it. Now let's try to understand scalability at more deeper level. When someone talks about scalability, it's after you understand the definition, of course. How do you scale is the next question. What kind of scaling options are available? Broadly, all of the scaling options are classified under two buckets. Okay, there might be more scaling options, but they somehow get classified into these two buckets, no matter how many other options come into picture. First one is called as vertical scaling, another is horizontal scaling. Now let's try to understand both of these via an example. Let's assume that you have a server in each of those scenarios, and this server is wanting for more capacity. The server, the number of requests that server is serving is already at the threshold and or nearing threshold, and you want to do some scaling. What are the options, right? Vertical scaling is adding more disk and processing power, adding more hard disks and adding more CPUs to your existing server and trying to increase the capacity of that server so that it can process more requests, store more files, or respond faster. Whereas horizontal scaling is not about adding more to the same server, but adding more servers. Okay, now this will add more servers, and when you add more servers, you're increasing the processing and storage capacity automatically. Because if you have one server with 4 gig RAM, I mean, servers are not 4 gig RAM, but just giving you a trivial example. If you have one machine with 4 gig RAM and a terabyte of hard disk, you add another machine, you have another 4 gig RAM and a terabyte of hard disk, with both of them having their own computation power, their own processing power. So this is another type of scaling. Vertical scaling is also called scale up. Okay, so you need to remember this for the exam or in the real world, because people kind of use scaling up and vertical scaling interchangeably, and scaling up is easier to use because it's a shorter, both words are shorter in this sentence. So people use scaling up most often than calling it vertical scaling. Horizontal scaling is called scaling out, because as you can see, you are scaling, you're adding more capacity outside of your existing server, and you're continuously adding more capacity in that direction. So that is why it's called scaling out. There are advantages and disadvantages to both. With the vertical scaling, it's very easy to manage because now you have only one server to take care of. Even after you kind of add more capacity to it, it is still one server. Okay, so you can, or whatever, like if let's say you had one personnel in the past to take care of one server, no matter how much capacity you add, you will still need only one person to take care of that server. Okay, you don't need any additional software, you don't need any additional hardware in order to manage this environment. But the problem is, it's a single point of failure. Now, remember this term as well. I'm sure most of you know it, but the people who don't know, you need to start getting used to this jargon. What is a single point of failure? Which means if something goes down in this server, if something goes wrong, the hard disk fails, or something goes wrong in the server, your entire application is down because the application is residing within the server and the application cannot work if that server goes down. So there is no backup strategy, there is no alternate way in which users can access your system. Now, horizontal scaling, obviously, because you're adding more servers or more machines to your existing topology, it eliminates single point of failure. If one of them fails, there are others to actually take care of the workload. However, this brings in new headache, the headache of distribution of workload, and the problem of now I have more servers. So obviously, I need more resources to manage those servers. Those resources can be human resources, or can be software resources, or can be complementing hardware resources. What do I mean by these 2 points? So distribution of workloads and management of these resources. For this, I need to bring in a load balancer, because when the request comes to my system, or request enters my network from a client, it is the responsibility of my system to distribute the processing of that request or send that request for processing to one of these three servers. Okay, for that I need to have additional mechanisms, and this additional mechanism is called load balancing. The next important non-functional requirement is performance. Now, performance is a measure of system in terms of response time and throughput, which means how soon the system is responding and how many transactions the system is able to process within a given amount of time. There are two factors that influence the performance. The first one is called the processing time, another one is waiting time. Processing time is nothing but the amount of time the system is taking in order to compute the result, package the response, and send the response over the network to the user. Whereas waiting time is when the system is trying to process something, but it has to wait because there is a step within the processing which uses a shared resource and system has to wait for the shared resource. There are various ways in which you can improve performance. The first one is to increase the computational capacity. So when you increase the processing power of the system will run faster. You have seen that with your own desktops and laptops. But this may not be a solution all the time, okay? Because there can be problems somewhere else, and that could be within your code. So you need to improve the algorithms efficiency and the code's efficiency so that you can write code in a better way, whether if it is database query, usage of indexes, if it is Java code, usage of hash maps, and usage of reducing the amount of loops, which are unnecessary iterations if they're not relevant, and also trying to send the response back to the user as a zipped content instead of the actual content will also reduce the payload and weight on the network. Those kind of things can be done. Use asynchronous processing. So there could be some steps within your application like logging, okay, like auditing. Now these two steps are totally non-relevant to the user, because you're doing these steps so that you can debug the application in case of an error. Now these can be done totally asynchronously, and you can use mechanisms like asynchronous logs, asynchronous JMS, and things like that. Third one is caching. Now, this caching can be caching of resources like connection pools or caching of the database results so that you don't have to fetch the result again and again and still deliver faster response time to the user. Third one is adopting a create once and use multiple times strategy. Now, this is, for example, if you have a screen or if you have a computed result which changes only once a day, you can probably use that computed result and cache it somewhere so that you don't have to compute it again and again. Use concurrent computation available. If it is in the database world, you can probably use the hint called concurrent so that the query can use all the processing capacity. Or in the latest Java version, you have things like streaming API, streaming collections, so that you can use computational capacity that is available at your disposal. Third one is deliver response times in chunks, if not immediately. It's like when you're trying to compute a result which has a list of items that you need to deliver to the browser, then deliver it in chunks, so that while you're processing in the background, user gets to see a portion of it and has a perception that the response time from the system is actually faster. Utilize all three layers of computation. I cannot say, I can talk about this for days. What you need to do is to understand how many layers you have and how many tiers you have, and make sure that your workload is distributed across the tiers so that you don't do all of your database related processing in your application layer and all of your presentation processing as well in the application layer. So you distribute it so that each of your tiers have some responsibility to take care of. Last one is reduce the network traffic by load once and use multiple times policy. Content delivery networks and things like that, which kind of deliver static content to the user faster, will definitely improve your performance. Now, these are the 9 steps. I'm not saying that these are the only ways you have to do it. There are various ways, but these are some things that are very notable, and you'll have to use these kind of mechanisms while doing your assignment submission. Okay, these are very very important for your assignment submission, and you'll have questions also asked in this. You may be given 4 choices. A question might look like this, right? So company X has a web server application and it is entire in nature, and then it is having performance problems, and you'll be given 4 options, and you'll be asked to choose one wrong option. And then you need to understand how each of these options is actually impacting your performance. Is it impacting or not? If it is not, then you remove the odd man out, and that will be the right answer. So this will take us next to the availability part. Availability is capacity of a system in ensuring that services are available for guaranteed amount of time to the required number of users. The first factor that influences availability is downtime. So when you have to do deployments into your system and you're bringing the system down, that is directly impacting availability. Generally, the availability SLA is 99.9% of the time, which means it's all of the time. When you hit it, like for example, take Google or Amazon, very seldom you'll see those sites going down. Maybe it's once in a lifetime kind of events when the sites go down, because they're truly living up to the SLAs, the architecture is truly living up to the SLAs and trying to achieve that 99.9% availability. So let's say you have a server and then you scale that server to like 3 servers. Then now you put a load balancer. Now the good point over here is you have 3 servers, which means the single point of failure is eliminated, and you have seen this picture already in the scalability concept. However, your balancer, the the load balancer over here itself is a single point of failure. Now, in order to avoid single points of failure, the first thing that you need to do is to build redundancy. Redundancy is nothing but creating an alternate mechanism in order to deliver the result, and that redundancy can be a standby load balancer, or that redundancy can be multiple servers that you have already put as a part of your cluster that we saw in the scalability aspect. There are two important concepts that you need to understand for the exam and in your real life, very important for the exam. Active replication. Now, active replication is nothing but all the requests that you're getting are sent to all of the components in your cluster, and then only one response is taken, and then it is sent to the user. Okay, so now let's assume that there is a database. Now you want to do replication of the database. In active replication, what will happen is you'll create 10 instances of the database, and you'll send that user's request to insert a record into all 10 instances. But when you get a success from one instance, you'll take that instance success, whichever is coming first, and taking and give to the user. Okay. Other is passive replication. Here you'll have one master server and remaining servers are slaves. They're on standby only. So the master server kind of takes care of the request, and it processes the request and sends the response. But the delta, the snapshot of that change that request has done, is kind of distributed to all the servers, and servers get synchronized offline. So this is about availability. Next, we will see maintainability and manageability. Maintainability and manageability are two non-functional requirements where people often get confused and they kind of try to mix them up, right? So you need to understand each of them so well that you should be able to differentiate them, because you may be asked questions which can get often confusing during the exam. Maintainability is an extent to which system allows correction of flaws in a component without affecting other components of the system. There was a correction that I had to make here. I missed the word without in my introduction video on non-functional requirements. I recommend that you insert that word whenever you are trying to refer to that screenshot that I recommended you to take before, right? Next one is manageability, is the ability to manage and monitor a system to ensure its health. So manageability is about managing and monitoring. Maintainability is about correcting the system without impacting other components of the system. Now, in order to enhance the maintainability of the system, your architecture and design should lay out a guideline which developers realize later, right? So developers realize the vision that you create as an architect, and your vision should encompass some of the best practices like loosely coupled components, modular code, cleaner code, which means code that is not cluttered in a certain way, and you'll have to emphasize on those aspects when you are kind of dealing with a development team and trying to help the development team understand the importance of maintainability. Externalizing the configurations will help in changing configurations in order to respond to a threat, or respond to some issue. uh, Clean documentation, and usage of design patterns. Now, these are the top 6 items that I can recollect, but there can be more items. We have to use just our practical sense when you look at a question in the exam and see that, okay, how is this aspect, or how is this activity improving one of the non-functional requirements, and what non-functional requirement is it improving? Okay. Next is manageability. Manageability is, as I said, ability to monitor a system. You have a cluster. However, you need to understand the health of each system inside the cluster proactively, not in a reactive way. When I say proactive, what I mean is you should be able to assess the health. If the cluster, if a system in a cluster is taking too much of a burden, then there is a problem in your load balancing algorithm. Okay, so how do you assess it? only by monitoring the health of the system, understanding how the database server or an application server is taking the load, and to what extent it can take the load. Next is dynamic system configuration. The system's configuration should be dynamic in nature. Um, uh, if you want to remove a server from the cluster, removing that server should not be causing any intermediate or permanent damage. Okay, adding a new cluster should not be causing any intermediate or permanent damage. System should be configurable in such a way that these kind of aspects can be managed very easily. At the same time, let's say you have four databases and there's one active and remaining are passive. At any point of time, you should be able to bring down the active and bring the passive up using deployment mechanisms that would not impact availability. Okay, see the cross connection. Your configuration monitoring should not impact availability. The next part is extensibility and reliability. Again, two concepts very important. What is extensibility? It is measured on how well the system support adding of additional functionality without modifying much of existing functionality. So what is the difference between extensibility and maintainability? Maintainability is about correcting the flaws. Extensibility is about adding new functionality. Okay, so you need to remember that in the exam too. People often get confused between maintainability and extensibility, and they kind of mix it up. For maintainability, you need to have loose couple code, very similar. For extensibility, you need to have loose couple code just like maintainability. You should have modular code just like maintainability. Patterns, see how they have a very similar way of handling or enhancing a certain aspect of non-functional requirement using the same activity, right? And then you need to use lightweight frameworks. You need to use the concept of interface and implementation so that you can replace that implementation with an enhanced version of implementation. And you need to do encapsulation, the basic object oriented concepts. Now reliability describes the ability of a system or a component to function under stated conditions at a specified period of time. This is very important. Reliability might sound like availability, but reliability is different. Availability is talking about my system is availability to take is available to take your request. Okay, that when you hit my system is not giving you a 505 or some other error. Now reliability is, though the system is available, system should perform reliably all the time, which means system should give the same response no matter how many users log into the system. Okay, system's response should not be different in terms of delivering the right functional computation that it needs to do, even though the number of users have increased or other aspects have changed. Whether system is more secure or less secure, system should be able to give the right result all the time in all conditions. One important concept of extensive reliability is mean time between failures. Remember this word, guys. MTBF, mean time between failures, is is a is a system's capacity in terms of recovering. How soon that it recovers. This is a measurement of reliability. Mean time between failures is not a measurement of availability. An important exam question again. So you need to remember MTBF is a reliability. It's nothing but the total start time minus total downtime minus uptime divided by number of times it failed. A very simple formula. You'll have to remember this formula too, because you may be asked a question in exam with three fake formulas and one right formula. You need to find the right formula in order to provide mean time between failures. The next aspect is security. Security is the degree of protection from harm. It applies to any vulnerable or a valuable asset, such as a person, dwelling, community, item, nation, blah, 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 right? But what is security in general? Security is about protecting. It is about protecting your resources from unwanted, malicious attacks and unwanted requests whose primary focus is to take your system down or break your system or try to expose data into your system. This is by far the most important aspect of OCMJEA exam. That is why, if you recollect all of the exam topics, there is a separate topic in itself called security, where you will have to understand various security aspects that Java E offers for you as an architect when you are developing and designing the systems. Okay, we will have a small we'll spend a little time right now, but when I do a video about security, I'll walk you through all the important examination concepts and all important concepts in general from a Java EE perspective when you're trying to secure or when you're trying to build a system which is secure in nature. Okay. For now, try to remember certain things. Now, in order to make sure your system is secure, you need to adopt some of many security mechanisms that are available. Now these security mechanisms can be out of the box, they can be coming in the form of libraries or third party products, or they could be something that you are implementing on your own as a proprietary security mechanism within your company. Okay, so cryptography, this is about encrypting and decrypting public and private key. um, TLS, which is a transport layer security, which was SSL before, formerly called SSL. Now, this is about securing your connection with the user's browser, via certificates, and you get into certification authority and all those concepts I'm going to explain when I do a video on security. Protection from top or all of your web attacks. Now, these web attacks can be denial of service. These can be man in the middle attacks, phishing attacks, somebody sniffing your data which is going between, or leakage of data from your log files, leakage of passwords, or the database is not secured enough, and things like that. All these are top web attacks. So you need to remember most of your web attacks, starting from cross-site scripting, SQL injection, till attacks like man in the middle, and that list goes on. Okay. Next is authentication and authorization. Very important concept again. I don't think there are any services except like openly available ones like Google's and stuff like that. But search engines are not like, you don't need to be authenticated in order to perform a search, but denial of a service on search engine is accomplished using a different mechanism, right? If Google finds that from a particular IP address it is getting continuously thousands of requests within a short period of time, then Google knows that there is something wrong happening, and they'll try to put a captcha or some other mechanism in order to have an additional layer of validation. But here we're talking about authentication and authorization in general, two different concepts. Authentication is ability to identify who the user is, and authorization is ability to assess what portion of the application the user has authorization to access. Okay, we'll talk about all these concepts in very detailed level in the security video. Then you have fine-grained access control. As I mentioned about authorization, you need to have firewalls. You need to put IP restrictions. If you have two servers trying to communicate over the internet, you should make sure that only those two servers can actually exchange, packets by putting IP restrictions on both of the servers, so that even though it is exposed on the internet, no other user can actually try to get access to that server, right? And then you need to do measures to avoid data leakage. Like for example, if you're logging something into log files, you need to make sure that it's encrypted, especially the user's sensitive data. Generally people have tendency to take an object, and when that object is when there is an exception, they kind of dump the entire object, but that object has some sensitive information. It can have PHI, it can have credit card numbers, or it can have other details. So that content should be encrypted. So when you're doing log4j, there are so many appenders and so many formatters and so many things that are available in the log4j world, and in general logging mechanism in Java E by default, which gives you that capability to encrypt some of the log files important content. So you need to make sure that that is also done. Now these are again only a top few, but as I mentioned in the performance topic, you will be given a question with 4 or 5 answers, and the question might be, can you identify a wrong method of enhancing security? And you should just pick and choose the odd man out, and then you need to remove that from the list. Okay, more on security in the dedicated set of videos just for security. I hope you enjoyed this content. Remember the word spammers, and that will help you recollect all of the non-functional requirement concepts which are most relevant. Beyond this, I still recommend you to go through Wikipedia and try to remember some of the other concepts as well, because each of them can also appear in the exam. It's a very open topic, but this will give you a kickstart into the non-functional requirements world, and will help you become a good architect. Good architect always tries to focus on defining the measurements for quality of service, which is non-functional requirements, and adhering to those measurements via service level agreements. Okay, thank you guys. See you again in my next video about one of these topics on the same exam. All the very best. Bye.